Hello and welcome. This is a short video whereby I talk about the introduction to chemistry. There are a few important ideas that you need to know when studying chemistry. Chemistry is the study of what? Atoms. It's a study of matter, as we call it. In chemistry, you want to discover or to understand chemicals. God has made chemicals, God made atoms, and we want to discover them. That's what chemistry is about. In chemistry, there are a number of words you need to know. Observation means to see or to watch. Measurements is how we figure out how much of something there is. So, for instance, 10 liters of water. That is a measurement of volume. Experiments are ways in which we test to see if a hypothesis is what? Is true. So a hypothesis is very, very important in chemistry and in all of science. And a hypothesis is a guess about why and how and so on. It's a guess why, how something happens. So let's say we're looking at a cloud and rain falling from the cloud. A hypothesis is a guess about how does rain fall from a cloud. You then do some experiments and you discover if your hypothesis is true. So you need to know about hypothesis, you need to know about experiments, measurements. More words you will need to know in chemistry. Theory. A theory is something that's more factual. Remember, in chemistry, as in all science, it is changing. Science is changing all the time. God does not change. Science changes all the time, but that's a good thing. Science must change because we're discovering God's world, and that's okay. The lab is the room where we do experiments, such as mixing awesome chemicals to make smells and fire. The lab tools, all different kinds of lab tools. Scientific method. I'm going to come to that in a moment. You need to know about the scientific method. But before we get to the scientific method, let's look at some more words. Graph. A graph is a way in which we present data. So here's a simple graph. You have your y-axis and your x-axis. And if we were measuring an experiment to see a reaction, we could draw the graph. Oh, the reaction is moving quickly, and then it slows off at the top. That's a graph. It's to represent an experiment. Types of chemistry: organic, inorganic, physical, analytical, biochemistry. All different branches of chemistry, and so on. Okay, the scientific method. Very, very important. Why? Because it's the way we do science. It's the way we do chemistry. If you play soccer, this is a very terrible soccer ball, my drawing skills are not great, and you are kicking that soccer ball, there is a way in which you kick a ball. Well, in chemistry, there is a method or a way in which you do it. And this is basically the method here. Observation, we see something happen. Hypothesis, we come up with a guess as to why that's happening. An experiment, we do the experiment to see if that's true. We see our results, and then the last one, which is in dark, I'm sorry you can't see it there, but it's basically our results. Is this true? And that is where the word theory comes in. Theory, the conclusion, the ending of our experiment. So if we mix two chemicals, here's one jar of a chemical, and we throw in a crystal, another chemical, and we see what happens. We have our hypothesis, experiment, and then we have our theory. Right, important. You must know scientific method. In chemistry, you also need to know about SI units. They are the standard international units of measurements, and here they are here. You must know them. These are them. The last one there, which is in dark, is pascals. which is a measurement of what? pressure. So let's say, for instance, you have a Coke bottle. Here's your Coca-Cola, and you shake it up, and then builds up pressure. That measurement will be in pascals. You must also know in chemistry how to convert SI units from kilo, so let's say kilogram to gram, or from gram to milligram. So we use the latter method. You can find this online, figure out how it works. But it's basically, it works by moving the decimal point, because each of these units of measurement, each of these points are in multiples of 10. So if we have 10,000 grams, sorry, 1,000 grams, and we want to convert it to kilograms, we go from small to big, so we move this to the left. 1, 2, 3. 1,000 grams equal to 1 kilogram. But if we want to move something big to small, let's say 10 kilograms, 10.00, we move it to the right. 1, 2, 3. So it's 10,000 grams. So if you move from bigger to smaller, you move this point to the right. If you move from smaller to bigger, you move it to the left. Significant figures. In chemistry, we work to 3 significant figures. So 6.68 grams. That's 3 significant figures, or 0.123. 3 significant figures. That 0 is not significant. Significant figures, must know. We're almost done with Introduction to Chemistry. Scientific notation. We do this because why do we have scientific notation? Because it takes too long to write very long or very short, very small measurements. So let's say we got what's it? 1, 2, 3, 4, 5, 6, 10 million grams of something. Instead of writing 10 million, we could write 1 times 10 to the 1, 2, 3, 4, 5, 6, 7. 1 times 10 to the 7. So 10 million grams is equal to 1 times 10 to the 7. Right? Understand it? Scientific notation is how we write very big numbers in a short way, because it takes too long. Or if we have 0.0000123, that takes a long time to write that all the time. So we could just write 1, 2, 3, 4, 5. 1.23 times 10 to the minus 5. See, we're converting using scientific notation. The last 2 things you must know in chemistry: rounding off, how to round off 6, 8, 7. If we have that and we want to round off to 3 significant figures, here's 3 significant figures. Because that's more than 5, that goes over to the next number, which is 9, so 6.69. There are other ways of rounding off. Make sure you know rounding off in chemistry. And accuracy, precision, also important. Precision is how close together your measurements are. So if all our measurements are here, that's precise. But if the accurate measurement is actually here, then these are not accurate. If that is the correct place that we should be, but we're here, then that measurement is not accurate. So accuracy is how close our measurement is to the real measurement. And precision is how close our measurements are. Okay, thank you very much for watching this video, Introduction to Chemistry. There's a number of important points here: significant figures, scientific notation, accuracy, and precision. There are many. There's the scientific method, there are the SI units. Make sure you know the SI units in chemistry, data collection, and the laboratory. Here's a quick quiz for you to enjoy. Thank you very much.